Ever feel that pressure to write, like, perfect code on the first try? You know, the kind that just flows and makes you feel like a total coding rock star?
I think every programmer has felt that at some point, yeah. Especially in those high-stakes coding interviews.
Right. But today, we're diving into why that whole perfect first solution thing might actually be holding you back.
It's kind of counterintuitive, right?
Totally.
We're supposed to think the best programmers just get it right away.
Our sources for this deep dive are all about iteration.
Interesting.
They argue that embracing imperfection, that's the key to unlocking this more powerful approach.
Makes sense. It's a bit like, I don't know, like we're so used to thinking about the end result
Totally.
that we forget about the process.
And they even advocate for this thing called a brute force approach, which honestly, when I first heard it, I was like, really? Shouldn't we be aiming for elegance, efficiency, all that good stuff?
We think so, and we'll definitely get to those.
Okay, good.
But think of brute force as like you're building a strong foundation. It might not be pretty at first,
Right.
but it forces you to really understand the problem. You're trying to solve it. It's about getting something functional down, even if it's not the most elegant.
So it's like creating that initial sketch, right, before you dive into the detailed masterpiece.
Exactly. Like you need to understand the anatomy before you try to, perform surgery.
Okay.
And this move forward solution, that becomes your baseline, your starting point for iteration and for improvement.
Okay, that makes a lot more sense. I'm starting to see how this imperfect approach, this could actually be really powerful. But how does brute force actually work in practice? Do we just start coding randomly, hope for the best?
Not quite.
Okay, good.
Our source material lays out a really clear step-by-step process.
I like those.
And the good news is it's all about continuous improvement, not about instant perfection.
Okay. I am all ears. What's the first step in this more iterative, less pressure-filled approach?
First step, resist the urge to just jump into code.
You mean like I usually do?
Probably like most of us do, to be honest.
Okay, true.
But really, like, before you write a single line of code, take a deep breath and make sure you really understand the problem you're actually trying to solve.
It's like that saying, measure twice, cut once.
Exactly.
Yeah.
Because sometimes we get so caught up in trying to come up with a clever solution that we miss really, really crucial details in the problem statement itself.
It's like trying to bake a cake without actually reading the entire recipe, right? You might end up with something, but it might not be a cake. So we've resisted the urge to jump into code. We've taken our deep breath. We understand the problem. What's next?
Now it's time to brainstorm. This is where you explore different potential approaches. Just jot down any ideas that come to mind, even if they seem crazy.
So we're talking about brainstorming before we've even ruled out the brute force method.
Exactly. Don't worry about good or bad ideas at this stage. Just get them all out there. You might be surprised at what solutions emerge when you silence your inner critic.
That's so true. I am my own worst critic. Okay, so we've laid the groundwork, right? We've got understanding, brainstorming. We've got this messy but beautiful collection of ideas. Now's the time to put on our hard hats and actually start coding, right? Is this where the brute force comes in?
You got it. Now is the time to implement that initial solution. Remember, at this stage, it's not about elegance. It's about getting anything that actually works.
Okay, this is starting to click for me. We've got our, well, possibly clunky, working solution. What's next?
Now comes the analytical part. You're going to take a close look at your brute force solution, and you're going to identify any inefficiencies.
Oh, okay.
Are there parts that are super repetitive? Are you using way more memory than you need to? Could you achieve the same result, but with fewer steps?
I see. So this is where we start to refine and optimize. This is where our coding skills really get put to the test. What happens once we've identified those areas for improvement?
It's back to the drawing board.
Back to the drawing board.
But this time, with a much, much clearer focus, because you've identified the weaknesses of your brute force approach. So now you can brainstorm targeted optimizations. And once you have some ideas,
We implement and test them out. It's a cycle: implement, analyze, optimize, and repeat.
exactly. You keep going through this cycle until you're satisfied with the efficiency and the elegance of your solution. It's like polishing a stone. You start with something rough, but with each pass, it becomes smoother and more refined.
I like that analogy. Okay, so we've got this iterative process down, but it'd be great to see it in action. The source material actually uses a classic coding problem as an example, the two-sum problem.
Ah, yes, a classic. and a perfect example to illustrate how this all comes together.
So for those of us who haven't encountered it before, what exactly is the two-sum problem?
Imagine you have a list of numbers,
Mm-hmm.
and you're given a target sum. Your goal is to find two numbers in that list that add up to that target.
Okay, that makes sense. It sounds simple enough on the surface, but I can already see how there might be different ways to solve it, some more efficient than others.
Exactly. And that's where that brute force approach comes in handy as that starting point.
Okay, so walk us through it. How would someone tackle this problem with a brute force approach?
Imagine you're trying every single key on a giant keychain to find the one that unlocks the door.
Right.
That's essentially what a brute force approach to the two-sum problem looks like. You would be checking every possible pair of numbers in that list to see if they add up to your target sum.
It's functional,
Yeah,
but I can imagine it might take a while, especially if you have a ton of keys on that keychain, so to speak.
exactly. And that's the problem with the brute force method. It can be quite time-consuming, especially if you have a really large list of numbers to work with.
So where do we go from there? How do we refine this key trying method into something more efficient?
That's where optimization comes in. By using a data structure called a hash table, you can dramatically reduce the number of comparisons that you need to make.
A hash table. Could you break that down for me a bit? I'm not sure I'm fluent in hash table.
Absolutely.
Yeah.
Imagine a hash table as a super organized filing cabinet
Okay.
where everything has its place.
Right.
It lets you store information in a way that's incredibly quick to retrieve later on. So instead of rummaging through a messy drawer to find what you need, you can go directly to the labeled folder.
Okay, so we've gone from a giant messy keychain to a well-organized filing cabinet. How does that apply to our two-sum problem?
In the context of the two-sum problem, you can use a hash table to keep track of the numbers you've already seen in the list and their corresponding indices. So as you go through the list, instead of checking every other number, you can quickly check if the complement, the number that would add up to your target, is already in your hash table. If it is, boom, get your matching pair.
That sounds way more efficient.
Exactly. Yeah. Using a hash table can significantly speed up the process, especially for those larger inputs.
So this hash table is an example of an optimization technique. Are there other tools in our coding toolkit that can help us write more efficient code?
Absolutely. Our sources highlight several other valuable techniques. They talk about things like two-pointers, sliding windows, even something called dynamic programming.
Ooh, those sound intriguing. It's like we're leveling up our coding skills with each new technique. Let's start with two-pointers. What's that all about?
The two-pointers technique is especially useful when you're working with data that's already sorted in a specific order. Like, let's say you have a list of names that are arranged alphabetically.
Okay, I'm picturing an alphabetized list of names. Where do the two-pointers come in?
Imagine you have two fingers, one at the beginning of the list and one at the end. Those are your two pointers. You move them towards each other based on certain conditions, like the sum of the values that they're pointing to.
So instead of going through the list one by one, we're strategically using our two-pointers to narrow down the search.
Exactly. It's like searching for a specific book in a library. Instead of starting at the beginning of each shelf, you can have one person start at the beginning of the library and the other at the end, and they meet in the middle.
I love that analogy. So two-pointers are all about working smarter, not harder, when dealing with sorted data. What about this sliding window technique? What kind of problems does that help us solve?
The sliding window technique. Particularly useful when you're dealing with problems that involve subarrays or substrings. Basically, smaller sections within a larger set of data. Think of it like using a magnifying glass to focus on specific portions of a larger image.
So instead of analyzing the entire image pixel by pixel, we're strategically moving our magnifying glass to focus on specific areas of interest.
Exactly.
Okay.
And that helps us avoid all those redundant calculations.
Got it.
Improves the efficiency of our code.
Okay, that one's starting to click for me too. It's all about focusing our efforts where they matter most. Now, for the million-dollar question, what about dynamic programming? It sounds a bit intimidating, like something only seasoned programmers use.
It might sound intimidating, but at its core, dynamic programming is about breaking down a larger problem into smaller, overlapping subproblems. A bit like building a complex Lego structure.
I'm intrigued. How do Legos relate to dynamic programming?
Imagine you're building a giant Lego castle. You wouldn't try to assemble the entire thing at once, right?
Yeah.
You'd start by building smaller, reusable modules, the walls, the towers, the drawbridge, and then combine those to create the final structure.
Okay, that makes sense. So instead of tackling the entire problem head on, we're breaking it down into more manageable pieces.
Precisely. And the key here is that you store the solutions to those smaller subproblems so you don't have to recalculate them every time you encounter them.
So it's like remembering the answer to 7 by 8 so we don't have to pull out our calculator every time.
Exactly. By storing and reusing the solutions to those subproblems, dynamic programming helps us avoid redundant calculations and write much more efficient code.
That's brilliant. It's like we're training our code to learn from its own work. Okay, we've covered two-pointers, sliding window, and dynamic programming. Are there any other optimization techniques our sources want us to add to our coding arsenal?
They do mention one more: divide and conquer.
Divide and conquer. That sounds pretty self-explanatory, but I'm guessing there's more to it than meets the eye.
You're right. It's about taking a larger problem and, as the name suggests, dividing it into smaller, more manageable subproblems. But here's the key. You solve those smaller problems independently and then combine their solutions to arrive at the final answer.
So it's like delegating tasks to different teams and then bringing their individual results together for the final product.
It's exactly. This approach is particularly effective for problems that naturally break down into self-similar subproblems. Think of it like solving a maze. You might divide the maze into sections, explore each section independently, and then combine your findings to navigate the entire maze.
All of these optimization techniques, hash tables, two-pointers, sliding window, dynamic programming, and divide and conquer sound incredibly powerful. It's like we've unlocked a secret level of coding.
Here are powerful tools.
It's like we've gone from using a butter knife to this whole set of precision tools, which I love.
Right.
But it's easy to get caught up in all these fancy techniques. Our sources also talk about the importance of this iterative mindset in those high-pressure situations, like tech interviews.
Yeah. That's interesting you mention that because it's a perfect example of where this approach can really shine, especially at those top tech companies where the interviews are legendary for their difficulty.
Right. Everyone's always talking about those FAAng companies, Facebook, Amazon, Apple, Netflix, Google. It's like their interview process is shrouded in mystery.
There's definitely a mystique around them, yeah. But here's the thing. Interviewers at these companies, they're not just looking for someone who can memorize algorithms or spit out the right answer. They're looking for problem solvers.
So it's not just about what you know, it's how you think.
Exactly. They want to see how you approach a problem, how you break it down, how you handle roadblocks, how you communicate your thought process. That's where this whole iterative mindset we've been talking about really comes in.
So even if our first attempt isn't perfect, the way we approach the problem, explain our thinking, that's just as important as the final solution itself.
Absolutely. In fact, our sources specifically mentioned that starting with a brute force solution can be a very effective strategy in these interviews.
Really, I would think they'd want to see the most elegant, most efficient solution right off the bat.
Not necessarily. Starting with brute force, it shows that you understand the problem. It shows you can come up with a working solution, even under pressure. And most importantly, it shows that you're able to analyze your own work, identify areas for improvement.
That makes sense. It's about showing your ability to think critically, to iterate, just like we've been talking about. But it's still nerve-wracking to think about being in that interview room. What are some key things I can do to actually demonstrate those iterative problem-solving skills?
Don't be afraid to think out loud. Talk through your reasoning.
Okay.
Explain why you're choosing a particular approach, even if you don't have time to fully implement all of them, suggesting potential optimizations. That shows that you're thinking about efficiency, that you're striving for the best possible solution.
So communication is key. It's not just about what I know, it's about how I explain it.
Precisely. And remember, even if you stumble or get stuck, the important thing is to keep talking, keep thinking, and keep trying to move forward.
This has been so helpful in understanding how to approach those interviews. What about after the interview? Our sources also talk about how mistakes, even those not so great solutions, can actually be incredible learning opportunities.
For sure.
Yeah.
It's so easy to get caught up in the need to be right, especially in programming, that we kind of forget the value of those mistakes.
There's that saying, right? We learn more from our failures than our successes. But in the moment, it doesn't always feel that way.
It rarely does, right?
Yeah.
Our sources actually suggest keeping a mistake journal.
Yeah.
I know it sounds a little counterintuitive,
It does.
but there's real value in documenting those coding blunders.
So it's like doing a postmortem on our code, kind of.
Precisely.
Nah.
When you hit a bug or you realize your solution isn't as efficient as it could be, Don't just fix it and move on.
Right.
Take the time to actually understand what went wrong. Where did your logic break down? Write it down.
Okay.
By documenting these coding autopsies, you're going to start to see patterns in your own thinking and avoid making the same mistake twice.
I love that. It's like having a cheat sheet for all the ways I've tripped myself up in the past. But how do we go from simply documenting those mistakes to actually, like, improving from them?
It's about analyzing the why behind the mistake. Were you rushing? Did you make assumptions about the problem? Did you misunderstand a concept? By pinpointing the root cause, you transform that mistake into valuable insight.
So it's not just about remembering what went wrong, it's about understanding why it went wrong.
Exactly. It's about turning those aha moments into lasting learning experiences.
This has been an incredible deep dive. We've covered so much ground, from embracing imperfection and the power of brute force to exploring all these optimization techniques and even delving into the art of learning from our mistakes. As we wrap up, is there a single most important takeaway that you hope our listeners will carry with them?
If there's one thing I hope listeners take away from this, it's this. Coding is a journey, not a destination.
Ooh, I like that.
Embrace the process.
Mm.
Start where you are with what you know and remember. Every line of code, every bug, every aha moment, it's a step forward on that journey.
Embrace the journey. I love that. And remember, as we've learned today, sometimes the wrong answer, it can lead us to the right solution, as long as we're willing to iterate, analyze, and never stop learning.